Hello and welcome to Lab 5, Choose Your Own Adventure, Falling Slinky by Joe Giuliano. So here we are. In this lab, a video of Slinky falling through the air on YouTube was analyzed using Tracker and GlowScript. And our purpose here is to observe and predict the motion of this Slinky using a computational model through GlowScript. So using Tracker and GlowScript, we created a computational model, but the results slightly differ from the tracker data, as you will see. So here are our principles and models. The principles in this lab are kinematics, coding and computation through GlowScript, the momentum principle, drag force, and equilibrium. And the models used in this lab are a scatter plot model, position versus time, and velocity versus time, a tracker model, and a GlowScript computational model. This lab is quite similar to Lab 2, as you will soon see, but instead of a projectile, we are analyzing the Slinky that is falling straight down. So we're only looking in the y direction. The equations needed and used in this lab are the force of gravity, which is 0, negative mg 0. The drag force, which is negative bv squared v hat. And Newton's second law, which is our position and velocity update formulas. Here are the initial conditions for our lab. So, as usual, we have the pink coordinate plane, and our origin is starting at the center of mass of where the Slinky is. And then in the blue, you can see that our height value is set to 1.75 meters, which we are just averaging the height of this man on the right. And our Slinky starts at rest. Its initial velocity is 0. We're also assuming that its initial position is 0, even though it's like 5.5 times 10 to the negative 16. That's just we're just going from where the origin is for our data. And then our Slinky's mass, as put in here, is 0.218 kilograms. So here's this experiment. If you want to see the experiment yourself, you can look at this YouTube video here. So what we did is we analyzed this video, as I will now play. And we put this video into Tracker and analyzed the movement of the center of mass of the Slinky. And we noticed that the Slinky's center of mass doesn't move until the top of the Slinky reaches the rest of the Slinky. And then the whole Slinky moves down together. And we put this data into GlowScript. And we used Lab 2's Projectile Motion Lab's GlowScript code as a skeleton for this lab. And we accounted for drag force, the Slinky's upward tension force, and gravity. And then we created an Excel model afterwards to compare our viewed data versus what was computed. So here's the experiment code. On the right, top right, we have our initial conditions as were stated in the previous slide. So B, as you can see here, is our proportionality constant. And that's just what we edit for the drag force. And then here's our delta T, which is 0.0165 seconds, which is what each frame was in our video. And then our calculation loop on the left is before the Slinky, or before the top of the Slinky reaches the rest of the Slinky. And here the net force is equal to 0 because the Slinky is not moving. And then on the right, we have our calculation loop when the Slinky is falling. And here there's a drag force opposing motion instead of a tension force. Here's our video model. And as you can see, it's stationary and then it falls off here. And so this is our Excel data on the right, as well as that position versus time graph that you just saw. And the tracker data is orange and the GlowScript data is green. And so possible errors here include tracker data being taken from a very fast video. So Tracker had a hard time processing the movement of the Slinky for each frame because the video was so fast. And so what went right? The computational model accurately represents the movement of a Slinky in this video. And the tracker data works for our analysis, and as well as our GlowScript runs smoothly, so there's no errors in our code. But what went wrong? So from the data in Excel, which is here, you can see that the tracker data is much different than our computed data. And this is most likely due to how the video was used in Tracker, and it wasn't very smooth. And large movements of the Slinky was only represented by a couple frames. And so to conclude, we have this video of the falling Slinky We analyzed it using GlowScript, Excel, and Tracker. And we used principles such as equilibrium, drag force, and Newton's second law. And while it did not turn out as intended, we were still analyzing Slinky's movement. And so here are assumptions and sources of error. So we had the Slinky's initial position, no drag force, the height, and then we had our source of error being that the tracker video was too fast and possible coding errors or tracking errors. And that's it. Thank you.